From functions to functional. Every C++ program has at least a single function. All real-world programs consist of hundreds or thousands of functions. Functions are one of the most fundamental software building blocks, and every developer who is aspiring to be good must be good at writing functions. But what makes a good function? First of all, a good function performs a single logical operation. That doesn't mean a simple operation, of course. Adding two integers is a single operation, but so is starting up a UDP server. On the other hand, if a function opens a file and also writes a string to it, then you need at least two functions. The second rule follows from the first one. A function that does one thing is typically very small. If there was only a single recommendation to give regarding functions, it's that functions have to be kept small. The most common anti-pattern is a function that does too many things and that is too large and that has to be split up. But how small is small? The common answer that is given in the wonderful book called Clean Code is that functions should be smaller than you think. In my experience, functions under 30 lines of code are the best. There is simply no way to do too many things in your function when it's so small, and that's what we're looking for. Let me show you a very good example of a very bad function. The author of this monstrosity is yours truly, and this is a good example of what is called software erosion. This main has started as maybe a few lines of code, and then I had to add argument parsing and exception handling and logging and so on and so forth. This is how functions grow too big. By adding one tiny thing at a time, we don't really make it much bigger, but then changes accumulate. There's nothing wrong with that, quite the opposite. This is a very natural way of writing code. First, we put everything in one place without worrying too much about structure and future maintenance costs. Unfortunately, the second step is often forgotten. Once the code does what we want, and before we ship it, we have to organize it for future maintenance. Large functions are a form of technical debt, something that developers hate and managers often overlook, but it is our duty as developers to allocate time for eliminating the technical debt. Let's see how we can reorganize this function. First of all, there's a rather large chunk that parses command line arguments. Right now there are only two, that is whether to run server or client mode, and also the log level. It's safe to assume that there will be more, so let's package all those arguments in a class and move parsing code into class constructor. It's nice to have an option class, because for instance, we could also add configuration file support later, and maybe other configuration related features as well. Speaking of parsing, notice the two relatively new features of C++ that I'm using here. First is std_span. We'll talk about it later in the course. Here, span provides a view into a chunk of the C-style array. This lets us use range-based for loop on all elements except the first one, because the first one always contains executable path. The other new feature is string view, which also provides a view, only this time into a C-style string, so we can use the same algorithms as we would with a normal std string. We could further split up this constructor. For example, the amount of if tests here might grow significantly, in which case we would want to write a smarter option parsing algorithm. But let's go back to our main. Now that the arguments parsing is extracted from here, main does fewer things but still too many. For example, it initializes a logger, so let's extract a function for that as well, and our function will accept program options because logger can be configured with command line arguments. The biggest thing that main does is running the program. There is a lot going on here, and we will certainly need multiple functions, and all these functions are going to need the logger, and some of them are going to need the IO context and maybe the thread argument. A situation with many similar functions that share the same data really calls for a class. For the lack of better definition, let's just call it program and let it keep the logger and program options as members. Now let's take what's left of main and move that into a single function called run. Now our main function is nice and compact because we've moved the mess into the run function. This mess has to be split further, like I repeated many times already, a function must do one thing, and error handling is a thing too. So, let run focus on error handling and extract everything else into yet another function, which I am going to call run.io context. Run.io context initializes the IO context, and then it either runs a client or it runs a server. So it seems very logical to extract running the server and running the client into their own functions and separate that from the initialization of IO context. So here's what we did. We split main into two classes, and every class consists of a number of smaller functions, each trying to do only a single thing. We can take this further and, for instance, split run.io context, but I hope this demonstration convinces you that splitting up a function into multiple is not only a must, but it's also relatively easy when you have a good understanding of the code. This is why it's important to watch the code you write and split functions into smaller ones while you still remember what the code does. And if you're working in a team, then very fine that every function does exactly one thing and is small should be on the checklist for code review process. When we were splitting up main, we had to create multiple functions and each one had to be given a name. And naming things is one of the most difficult things in programming. While every function is different, there are certain naming conventions that really help. First of all, a function name should describe the one thing that the function does. Sometimes, of course, a function would do two things. It has to be avoided, but sometimes you will do it. And in that case, it's best to reflect this in the name. It's only natural to derive function names from English phrases, and you should do it that way. For example, stop all servers is quite a self-explanatory name, which barely requires any additional comment. Functions can be split in two large groups. These are the functions that perform commands and functions that query something. And the first kind of functions, the ones that perform commands, such as terminate, should have a verb in their name, while functions that do queries, like for instance maximum or size, do not need a verb in their name. The possible exceptions include getters, which can be prefixed with get even though they're just a query, but that's just to make them consistent with getters.